In exercise 20.2, they're giving us the names of either aldehydes or ketones, and they're asking us to draw them. So you start by drawing the backbone. The backbone is the last carbon, or is everything that comes after the last YL. So you're reading the molecule, you have a bunch of branches, you see your last YL. Everything after that is the backbone. So here the backbone is cyclohexanone. Okay. So let's start by drawing the backbone. Cyclo means we're going in a ring, and hex means we have 6 carbons. So that's going to be a 6-carbon ring, looks sort of like a hexagon. The infix is AN, so we're going to have all single bonds within the ring, and the suffix is ONE. That's telling us that we have a ketone. Now they don't tell us where to put the ketone, and the reason for that is wherever we put the ketone, that will be carbon number 1. So we could put it anywhere we want. We just have to make sure we number that as carbon number 1. I'm going to put that at the top. Now we're drawing the molecule, so we get to number this however we want. We have to put the 1 where we put the ketone, otherwise you could choose to go either way. I'm going to go clockwise. Now, the first branch that I see is this ethyl branch that's on carbon number 4. The prefix eth means that we're dealing with 2 carbons here. So on carbon number 4, we're going to have 2 carbons coming off. So there's our 4-ethyl. We have 2 more branches. They're both coming off of carbon number 3. They are both bromines. So we have 2 bromines coming off of carbon number 3. So that's 3,3-dibromo. Last, we have to think about this S. Now they don't tell us where the chiral center is, so we have to think about where it is. The only carbon that is bonded to 4 different things is this carbon at the bottom here, going to the ethyl group. That has this sort of ring with the bromines on it to one side. It has a ring without bromines on it to the other side. It has the ethyl group, and the last thing it has is a hydrogen. Now that's implied, but it's bonded there. So that carbon is bonded to 4 different things, which makes it chiral, which means it's going to have a left-handed version and a right-handed version. And we have to draw it so that we get the S, or left-handed version. So the question becomes, okay, here are 2 carbons. What type of bond should we draw there? Should we draw a solid wedge so that it's coming out? Should we draw a dashed wedge so that it's going away? Which one will give us an S? And the point is not to belabor this. You don't really want to waste a lot of time imagining it. Pick one and then see if it works, and if it doesn't work, then do the other one. The first step, of course, is to assign priorities based on the groups. So that you're going to do based on the atomic numbers of the different groups. Hydrogen has the lowest atomic number, so it's going to get the lowest priority of 4. For the other 3 carbons bonded to the chiral center, those are all carbons, and so they all tie. When atoms tie, you make a table. So I'm going to make a table for the carbon on the bottom, for the carbon on the right, and the carbon on the left. This carbon on the bottom, going away from the chiral center, is bonded to a carbon and 2 hydrogens. So I'm going to put those in the table in descending atomic number. So carbon and 2 hydrogens. The carbon on the right, going away from the chiral center, is bonded to 2 bromines and a carbon. So I'm going to put those in descending atomic number. Bromine, bromine, carbon. And the carbon on the left is bonded to, going away from the chiral center again, a carbon and 2 hydrogens. So I'm going to put those in descending atomic number, carbon and 2 hydrogens. Now once you have these tables, you don't compare them all together, you just look at one row at a time. You start with the top row, and only if everything ties would you go to the next. Now we can see that the left 2 carbons, these 2 carbons tie, but the one on the right doesn't. Bromine has the highest atomic number, and so this carbon on the right is going to be the number 1 priority carbon. So that already wins that. Now we have to choose between the 2 others. The first row ties, so we go to the second row, but that ties too, so we go to the third row, but that ties too. So we have to go to the next carbon in these chains. Now, we just did, on this branch, we just did this carbon. The next carbon over is this one here, so that's a carbon. In this other branch, we just did this one. we're going to go to the next carbon over, so that's this one. Now these are both carbons, so they tie, so we want to make a table for each. This carbon here, going away from the chiral center, is bonded to 3 hydrogens. This carbon, going away from the chiral center, is bonded to a carbon and 2 hydrogens. So in descending atomic number, carbon and 2 hydrogens. So now we have those 2 tables and we can compare them one row at a time. First, just the top row. We can see that the carbon in the top beats the hydrogen in the bottom. And so the branch that has that carbon, this branch over here, will get the higher priority of those 2. So that'll be priority 2, and the ethyl branch will be priority 3. Okay, now that we've done that, I'm going to erase the tables so that it looks a little less crowded and confusing. So the first step is always to find the priorities of the 4 different branches. And now we're not going to belabor the point. We're just going to choose one of those possibilities of the types of bond that we can draw. I'm going to draw a bond coming out. Who knows if that's the correct bond? We'll try it. If that's coming out, then the hydrogen has to be going away. That's because these tetrahedral atoms will always have 2 bonds in the plane, one coming out at you and one going away. So if that's the case, we have all the priorities. The second thing you want to check is that 4 is going away, which it is. And then if you go from 1 to 2 to 3, we're going clockwise. Now it's clockwise, and so, we're going counterclockwise. So it's counterclockwise, and so that is a left-handed molecule, S. We don't have to switch anything because the number 4 thing is pointing away. So that is the correct drawing for that molecule. That gives us an S at the chiral center. Now that was by pure chance that we got that right the first time. What if I had chosen the wrong thing? What if I had said, well, let's try with this ethyl group going away and the hydrogen coming out at us? We would have checked to see if the 4th priority was going away. In this case, it's not. It's coming towards us. Okay, so we keep that in the back of our minds. And we go from 1 to 2 to 3, it's counterclockwise, but the 4th group is going away, so you switch it. It's counterclockwise, so you'd think it would be S, but the 4th group is coming towards us, so we switch it, and it would actually be R. And that would give us the wrong chiral center. And so once we see that, we're saying, we don't want R. So you'd switch these arrangements. And that gives us the correct answer. Okay. B. We want to draw 2,4-dimethyl-3-pentanone. Well, we're following along. We see our last YL. That means everything to the right of that is the backbone. So 3-pentanone is the backbone. The prefix pent means we have 5 carbons. So 1, 2, 3, 4, 5. We're numbering this, so we're drawing this so we can number it however we want. I'm going to number it left to right. The infix is AN, so that's all single bonds, and the ONE suffix means we have a ketone. Now, a ketone can be anywhere in a chain, and so they give us a number to tell us where that ketone is. It's on carbon number 3. So there's our ketone. So that's 3-pentanone. Okay. We also have branches on the molecule. We have 2 of them. They're the same type of branch. They're both methyl branches. That means they're both going to have 1 carbon. One of them is coming off of carbon number 2, and the other is coming off of carbon number 4. So those are our 2 methyl groups coming off of carbon 2 and 4 of 3-pentanone. And so that is 2,4-dimethyl-3-pentanone. Okay, with C, they want us to draw R3-bromobutanol. Well, we don't have the YL here, but we do have the O from halogens. Remember, when halogens are branches, they end in an O. And so that's our last branch. So butanol is our backbone. But, that prefix means we have 4 carbons. So 1, 2, 3, 4. We are drawing this molecule so we can number it however we want. I'm going to number it left to right. The infix is telling me that inside that chain, I don't have to draw any double bonds or triple bonds. They're all single. And then the suffix Al is telling us that we have an aldehyde. Now, an aldehyde is a carbon double bonded to an oxygen. with a carbon with a hydrogen on one side. And so it's always at the end of a chain. I'm going to put it on carbon number 1. You always want to number the chain to give the most important functional group the lowest number. And in this case, there's only one functional group, and it's the aldehyde. So it wants to get the lowest number. So that's butanal. Now on carbon number 3, we're going to have a bromine, this 3-bromo branch. So in carbon number 3, we're going to have a bromine. But the question is, what will that bond be like? Will that bond just be a regular straight bond? If it's not, that would be the case if it's not a chiral center. Will it be a dashed wedge, or a solid wedge, or a dashed wedge, if it is a chiral center? So we know that we have this bromine here. The question is, what type of a bond should we draw? Because that is a chiral center now. Notice that this carbon is bonded to 4 different things. It's bonded to a methyl group on one side, it's bonded to a bromine, it's bonded to a weird carbon chain that has an aldehyde on it, and it has a hydrogen, an implied hydrogen, but a hydrogen. And that is the 4th thing. So that carbon is going to be bonded to 4 different things, so it's a chiral center. It'll come in left and right-hand versions that will fit into pockets differently, and so we have to say what version we have so we know what pockets it'll fit into. Well, the name gives us the R. So that needs to be a right-handed chiral center. The first step in assigning that is assigning priorities based on atomic number. Hydrogen has the lowest atomic number, so it'll be number 4. Bromine has the highest, so it'll be number 1. But we have 2 carbons, and those tie. And so anytime the atoms tie, you make a table. So I'm going to make a table for this carbon at the right and this carbon at the left. The carbon at the right is bonded to 3 hydrogens. So I'm going to draw those in my table. The carbon on the left is bonded to a carbon and 2 hydrogens. So I'll put those in my table in descending atomic number. Now you don't look at the table all at once, you just look one row at a time, starting with the top, and we can see that the carbon on the left is bonded to a higher atomic number atom than the carbon on the right, and so that gets the higher priority. That's number 2, and then this gets a priority of 3. So that's the first step, just assigning priority based on atomic number. The second step is to make sure that 4 is going away. Now, we don't know if that's going to give us the correct configuration, but we have to try something. So let's try the easier thing. That's where 4 is already going away. All right, if 4 is going away, then all we have to do is go from 1 to 2 to 3. Here we're going clockwise, and so that's R. You can remember because going from the top to the bottom in R, you have to go clockwise. So that's the right-handed version of the molecule. That's what we want. And so that is the correct way of drawing this molecule. Now, again, that's pure chance. What if I had instead done it the other way? What if I had said, well, what if the hydrogen's coming out at us? In that case, the bromine would be going away. These tetrahedral carbons always need 2 bonds in the plane, one coming out at you and one going away. So in that case, you'd say, oh, 4 is going away, we have to make a note about that. When we go from 1 to 2 to 3, it looks like it's R, but because 4 is going away, you'd switch it, and it would, or because 4 is coming out at you, you'd switch it, and it would actually be S. So when the 4th group is pointing out at you, you always switch the configuration that you would otherwise think you would get. Well, S is not what we wanted, and so we would know that we would have to switch those bond configurations. So the hydrogen is going away, and the bromine is coming out. And that gives us our original answer. So that's some practice with drawing aldehydes and ketones when you're